I hate this term big data. It's not really going to be about big data, it's going to be about data. Because I will predict for you that in 3 years, we don't use this term big data anymore. This is a stupid term invented by a bunch of marketing people who mostly don't even know what it means anyway, right? I'm in fact going to focus more on open data than big data. Now it turns out that open data is in many cases also big data by the definition of the industry. The focus is on innovation and data and how we need to think differently in terms of creating value from the data that we have in the open source domain, in the open data domain, as well as in the corporate world. So to start out, my proposal is that if you're going to be successful, we need to think differently about data. Right? And in Silicon Valley, which is where I'm from, we have a saying that in the 21st century, all companies either are data companies, will be data companies, or will be extinct. Those are the only three options. So we need to rethink about what our assets are and how we create value. I'll give you an example, semi-local example. In the Netherlands, Philips, right? We all know Philips, create lots of consumer electronics and lighting products and so on. They've woken up, right? They understand that this transformation is going on. And if you look at, for example, their connected health initiative, it's not actually about the devices that are being manufactured. It's about the data being created by those devices and how you create value from it, right? So let's take something very inane, like an electric toothbrush. Of course, Philips and others have been selling these electric toothbrushes for decades. And we buy these electric toothbrushes and, you know, every 5 or 8 years we replace them because they get old and they stop working or whatever it is. And maybe they would like us to replace every 6 months these brushes, but probably we do it every 9 to 12 months, right? And so the relationship in the past has been this very transactional relationship about selling the electric toothbrush and selling the brush replacements. Right? Imagine a world where when you're brushing your teeth, the electric toothbrush is part of the Internet of Things. And it's collecting data about your toothbrushing habits. Now, it's your data. Let's not be confused. It's not Philips' data. It's your data, right? Your toothbrush, your data. Right? Some of you may have small children, right? Do you sometimes say, Joey, did you brush your teeth before you went to bed? You don't have to ask anymore. You just pull up the scorecard for Joey and say, yes, Joey brushed his teeth. By the way, he spent too much time in the back and not enough time in the front, right? And you can decide, it's your data, whether you want to share that data with your dentist or not, so he or she can give you better dental hygiene, right? Your choice. Maybe you do, maybe you don't, depending on your brushing habits, right? But think about this as a business model. It's completely different than selling electric toothbrushes. It's now about how do you add value with the data, right? The relationship has now completely changed. Now it's a 3 times a day relationship. It's not a once per year I'm replacing the brushes and once every 5 years I'm replacing the electric toothbrush relationship. Very different, right? And in fact, now it's a relationship directly with the consumer, because if you're somebody like Philips Electronics, in the past you didn't actually know the consumer. You sold it to Walmart and then Walmart sold it to the consumer. You had no direct relationship at all. Now you're providing a data as a service type of model, and the analytics on that data becomes very, very interesting. So think of the data as the product, right? And think about what you can do with that data. I'm going to give you an example that comes from a very boring industry, and I'm going to choose a boring industry on purpose, because if this industry can do it, any industry can do it, okay? And the fundamental recognition is this evolution from business intelligence, which we've been talking about for 25 years, to consumer intelligence. What's business intelligence? We're providing information to business decision makers to make better decisions for their company. Traditional BI type of model, right? Consumer intelligence is, can we provide the data and the tools to the consumer, to an individual, to allow them to make better personal decisions, right? Very, very interesting. So now I'm going to use my data not just for my own company decisions. I'm going to use my data to help my customers, my consumers, to make better decisions for themselves. So here's a very boring industry. Power utilities. Right? So power utilities, at least in the US, these are basically government-granted monopolies. Right? They have no competition because of economies of scale and so on. Doesn't make sense to have two electric utilities in the same city and so on. So they're basically given a monopoly. And when you don't have competition, then it's not really that important to innovate and so on. But in fact, there is a lot of innovation going on in this industry. And I'm going to use Southern California Edison as an example. This is a California utility based in Los Angeles. So they more or less cover the people that live north of San Diego and south of Santa Barbara, if you know anything about the geography of California. Okay? They went through a process of smart metering every residential home in their coverage area. They spent over $1.6 billion doing this, with a little help from the government, I will admit. Right? We'll come back to this point later on. And this is pretty fundamental, right? When I was a kid, right, there would be someone who would go house to house, and they'd climb over your fence, and they'd read the meter, and they'd write it down in a little book, and then they'd bring the book back at the end of the day, and someone would do data entry, and then you get a bill at the end of the month. That's how it was done, right? And so you had the consumption of electricity, basically one number in a month. This is how many kilowatt hours you consumed, and this is how much we're going to charge you for it. Right? This granularity of data is not very useful. Right? Smart meters allow us to collect data on a continuous basis, right? As much detail as we want. Right? So why is this important? Well, in Los Angeles, there's a problem. Right? In the middle of the week, in the middle of the summer, on a hot summer day, there's not enough electricity. There's not enough because people are at home and they're watching their big screen televisions. They've got their air conditioner on full blast. They're doing the laundry in the back room. And if everybody's doing that, there's not enough electricity to go around. Right? And so there's this technique called load shedding. Right? Where basically you take a 10 square block area and you turn off all their electricity for a very small amount of time. And then you move it to another 10 block area and another 10 square block area. You move it around. So nobody's impacted by very much. You know, the refrigerator isn't down long enough to make your food go bad and so on. But it's actually very annoying because now your clocks are flashing and you have to go reset them, and you know, you're watching your big screen television, and right before the most important scene where this guy is going to kiss that gal in your soap opera, it's gone. People are very annoyed, right? And they call up and they complain. Right? Why isn't there enough power for my home? Well, the reality is that this only happens once or twice per year. Doesn't happen very often. And if you are the CFO for Southern California Edison, say, I'm not building another power plant. Are you crazy? On average, we use less than 50% of the capacity of our existing power plant. Why would I, for 1 or 2 times per year, we have these huge spikes because it's a really hot summer day, you know, in the middle of the week, you know, in the middle of the day, why would we build another power plant for that? Makes no sense. So they use other techniques, right? They will beg, please don't do your laundry in the middle of the day, in the middle of the week, and so on. Please don't do it. We'll take out television ads and so on. And begging worked for some people, right? There's another technique that works even better in California, guilt. You are not green. if you were using electricity to do your laundry in the middle of the week, in the middle of the day, and so on, right? You were not green. If you're not green, you're definitely a bad person. Not green people are bad people, right? And we will make you feel very guilty for being a bad person, right? You should do your laundry at night and on the weekends, and it will be much better for the ecology, for the earth, right? It works for some people. In LA, it actually works pretty well. But in LA, there's another kind of green that works much better, right? That's dollars, right? If I can price differently in your consumption in the middle of the day and in the middle of the night, I can influence you to do your laundry in the middle of the night because it will be cheaper, right? So maybe I can make you feel guilty, but if I can make you feel richer, that's even better, right? And so from a business intelligence point of view, Southern California Edison, right, they do lots of interesting analytics to understand, what is the price elasticity related to electricity, right? So price elasticity says, if I change the price by this much, how much does demand change? And they're very interested in the difference between lost demand and deferred demand. So if I raise the price of electricity in the middle of the day by a little bit, then I can influence you to do your laundry on the weekend or in the middle of the night. That's deferred demand because your laundry's still dirty. You're still going to do it. You're just going to do it at a different time. And I'm still going to collect my money for those kilowatt hours that you consume during your laundry, right? But if I raise the price by too much, then the consumer says, I would rather sweat than pay your bill. And if I'm really sweaty today, I'm not going to turn the air conditioner on double high on the weekend. No, you've lost the demand. Right? So there's a big difference between lost demand and deferred demand. And these econometric gurus within the company figure out how we can do the price to sort of retain demand but defer it so we can do sort of better balancing of the demand for electricity within our power plants. It's very interesting business intelligence analytics. And it's enabled by the fact that they collect this sensor data. And sensor data is definitely big data, by the way. Sensor data makes all other data look like tiny data. There are not enough monkeys on keyboards using Facebook to create the social media volumes that sensors will create everywhere, right? So sensor is the next generation of big data that people don't even realize is going to hit them yet, right? But these sensors are going to be everywhere, right? Your vehicle will be sensor enabled. Your body will be sensor enabled. I don't see too many people here with Fitbits or Apple Watches, but these are sensors, right? Your house will be sensor enabled. Google acquired a company called Nest. Why did they do that? Because that is sensor technology, and if I have sensor technology, I know what you're doing. And Google definitely wants to know what you're doing, right? And so this sensor technology will proliferate everywhere. So in Southern California Edison, there's this very interesting business intelligence that we can do with the sensor technology. But in fact, this is not really thinking differently. It is innovative use of big data, but I want to think differently, which is along the lines of this consumer intelligence, right? If you look at the relationship between Southern California Edison and their customers, right? Once a month, the customer gets a bill. And then they pay that bill, hopefully online, but my grandmother still writes a check and puts it in an envelope, right? But they pay however they pay, right? And it's not really a great relationship per se, right? I mean, getting a once a month bill is not something I really look forward to, right? And the other time that I have a relationship is when, my power isn't working and I call up to complain. What they're now doing is they're engaging with the consumer and allowing the consumer to get direct access to their own data. So this is what I call consumer intelligence. So you can go online to SCE.com, SouthernCaliforniaEdison.com, and you can see your data, your consumption of power, right? So they are allowing consumers to access their enterprise data warehouse. It's very interesting. So the same data that's being used by their business intelligence econometric gurus now being available to the consumer. But of course, the consumer can only see their own data. I can't see my neighbor's data. I can only see my data, right? So it's a very selective sort of access to the data based on, the same password that I use to log into my account to pay my bill, I can use to log in and see my data, right? And then I can start profiling what's going on, right? So most of you would have probably heard of smart home initiatives. This is really part of smart home initiative, right? This is an actual screenshot from the iPad of a friend of mine. Okay? So this is not some corporate thing. This is a personal guy. Okay, he's a geek, I admit it, right? But I think most of you are also, so that's okay, right? He would be here if he could, I'm sure. And he will basically, he takes the feed from the power company and he actually can analyze his use of power, right? And how much he's paying for it. And he installed all kinds of solar power. So he's actually able, in California, if you get solar power, you can sell it back to the electricity company. What you don't use, you can sell back, right? So he can actually monitor sort of the electricity he's consuming. He can also monitor the electricity that he's producing and selling back and how much he's getting. And it's very, very interesting, right? And he can go into even more detail, right? So yes, he can see the home power that he's consuming, right, and how much he's producing, right? So it's at nighttime right now, so it's not very much, right? Solar power, not so much at night. But he can measure, all kinds of different things, and we can go beyond just the power stuff, right? I can measure the temperature, I can measure humidity, I can measure noise pollution. How much noise is happening around your house, right? Is it the kids or is it the neighbors, right? So you can start to measure everything. Right? So think about how you can use data to make people smarter. Now, I'm not saying that everybody is as geeky as this friend of mine. Not everybody's going to get really excited about looking at all of their smart home metrics. Right? Different people are motivated by different things. Right? Other people will be motivated by the Fitbit or the Apple Watch and looking at their sort of healthcare metrics. Some other people will be interested in looking at their driving metrics. Some other people will be interested in looking at their financial metrics. But in the new world of consumer intelligence, data makes me smarter. And I want the people delivering value to me to deliver that value through data. I want my bank to give me tools to access that data, right? And it's already happening. Lloyd's banking group in the UK, Wells Fargo in the US, Bank of Shanghai in China. The smarter kind of leading banks, Westpac Bank in Australia is another one. They're figuring out how we can deliver value by sort of exposing people to their own data. It's a value-added service. Now, I will point out that in most cases, the consumer will not pay for this service, right? They will not. It's my data. Why should I pay for it? Right? It gets bundled into the bigger picture of the value-added services, and it creates loyalty and those kinds of things. But don't expect that you're going to be able to pay them, or get €3 per month to have access to the data. That's not going to happen. All right? But it's very interesting when you start to change the relationship in this way. Right? And it's going to impact all industries. All industries. This consumer intelligence idea. So the direction that I'm taking you is that data becomes a resource of the consumer. And in many cases, there are opportunities for open data as well that can be created by governments, which is very, very powerful. Right? So as was said in the introduction, I was part of Barack Obama's Council of Advisors on Science and Technology in his first term. And in his first term, he made a strong suggestion to all government agencies that they should start publishing all of their data. Right? And that really means everything. That even means, who are the people that are visiting on the appointment log? Which is interesting because it gives transparency to who the lobbyists that different politicians are talking to and so on. crime figures, educational scores, not in the individual basis of a student, but the educational sort of capabilities that the quality of education the school is delivering and so on. And some of this, by the way, is very political, right? Because, this neighborhood says, no, we want to, publish our crime figures because then everybody will think we're a bad city. Well, maybe you are. And maybe the transparency will help you become a better city, right? So one of the sort of ideas behind this open data initiative is that transparency is goodness. If you're trying to hide, then we shouldn't allow it, right? Publish the data. Now, don't publish the data to the point where it violates privacy, right? But give transparency. And one of the first things that Barack Obama did in his second term of the presidency was to make it law. So in the first term, it was a strong suggestion. In the second term, it became law that all government agencies will publish their data unless it violates privacy or security, right? So now it becomes law, and now it is law, right? And I think it's interesting to talk about what are some of the opportunities associated with open data, right? So here's a very simple example. How many people here have ever used weather.com? Almost everybody. Isn't it great, right? It's free. But that data actually comes from, right, NASA. It's government data, right? At least in the US. There are other sources in other countries and so on. But the National Aeronautics and Space Administration sort of creates a bunch of weather data and put it on a bunch of servers and use weather.com. Weather.com is actually not a government website. I think that's a good thing, by the way, because governments are not very good at innovation, right? So my view is government's job is to put the data out there and get out of the way. All right? This is something I think that the Obama administration did very well, right? Because some governments, they want to put it out there and then they want to own it and they want to add all the citizen services and all that kind of. This is a huge mistake. Let the kids in their college dorm rooms and the innovators in this room and entrepreneurs all over the world, let them innovate because they will be much more effective than some government organization trying to think about what citizens want, right? And weather.com, they don't charge you money, but they monetize through advertising and so on, which is fine, And different people will come up with different models for how you're going to sort of create value and how to monetize the value. What's even more interesting is if you take multiple data sources and you put it together, right? So weather data can be used by retailers. For example, there's a great YouTube out there about how Tesco's uses weather data to predict demand in their grocery stores for certain products. It's a BBC special, and they talk about using supercomputers to analyze all that data. In your mind, by the way, when they say supercomputer, you should translate that to Teradata. Right? So that's really what they mean. So Tesco's will use the weather data, their demand data, their customer data to do very interesting things. And insurance companies will use weather data to, for example, understand the impact of floods and hurricanes on their insurance liabilities. There's all kinds of things you can do with weather data. But it becomes even more interesting when you start integrating different kinds of data. There's insurance that you can get in the US. If you're a farmer, farming is kind of a tough life because there's a lot of ups and downs. When you get a sort of good season with good weather and lots of crops, you make lots of money. And then you hit a drought, and then you don't make lots of money anymore, right? And so the income goes up and down. And so there's an insurance out there that will guarantee a certain level of income regardless of what happens with the crop yield. But of course, the insurance company, if I take out insurance and I start growing corn in the middle of a desert, that's not so good, right? So the insurance, of course, has to understand the quality of the soil and the weather and so on, and insurance will have different costs depending on the probability that your crop yield is going to be good or bad and so on. And that comes when you start pulling data together. And by the way, quality of soil is also something that the government surveys. It's a completely different agency than NASA, right? There's actually a geological survey that gets done that looks at soil quality and so on. And when you start putting these open data sets together, you get to do even more interesting things. Right? So the McKinsey Global Institute did a very good study related to open data and value creation for open data. It's a free report you can download from the web. Just Google for McKinsey Global Institute and open data, you'll find it. And they estimate that there is a potential for over $3 trillion in value that can be created from open data on a yearly basis. This is really interesting, right? So if I'm trying to innovate, if I get even a small percentage of that $3 trillion, I'm probably a pretty happy guy, right? So how can you sort of create value? Now, you have to be a little bit careful because, of course, consultants like to throw out these big numbers, right? Because then it makes you very interested in getting their consulting services to figure out how you're going to sort of get your piece of it. But let's look at some real numbers. So the $3 trillion is an estimate. Let me give you an example of some real numbers. In the US, GPS data is open data. Right? It wasn't always open data, by the way. Right? GPS data in the past was closed data, and it was held by satellites, and it was mainly used for sort of US military and other type of purposes. Right? And the interesting thing that caused that closed data set to become an open data set was actually a tragic accident. Right? Most of you are probably too young to remember this, but there was a South Korean airliner that by mistake, and it was a pure passenger plane, completely innocent, not a military operation or anything, just a bunch of passengers, right? They drifted into Russian airspace by mistake, and the Russians shot them down, and lots of people died. And at that time, Ronald Reagan was the president of the US, and he said, this is a tragedy that's unacceptable. We could have prevented it if we had our GPS data available to that that South Korean pilot. This wouldn't have happened, right? So that's actually how the GPS data went public. Right? It was really in the interest of aviation safety. But then what happened is a huge industry got created around it. Today, there are over 3 million jobs in the US that are directly related to exploitation of open GPS data. Over 3 million jobs, right? It's estimated that just in the US economy, I'm not talking about in Europe or Asia or anywhere else, just in the US economy, over $90 billion per year is created based on GPS data. Right? Just as a simple example, how many people here use Waze? Waze? People, yeah, most of you use it. That's based on a combination of open GPS data and social media data. Right? It's basically a combination of those two things. It was an Israeli company that was bought by Google for roughly $1 billion. Right? All they did was take open free data, GPS, and social media and did some interesting things with it. Right? So the value creation there is pretty interesting. McKinsey has a nice framework in this paper that I suggest that you download for thinking about the openness of data, because now open data is a big buzzword among governments. Every government wants to be open data, right? And you have to think about what really does it mean to be open data. So accessibility, who is allowed to access the data, right? For example, the AMA, the American Medical Association, they have a data set related to healthcare and outcomes and best practices in medicine and so on. But you're only allowed to access that data if you're a member of the American Medical Association. So if you're a member of the Belgian Medical Association, well, tough luck, right? So that doesn't really count as full open data. It's kind of partially open data, right? It's open within the club, but it's not really open. Right? I'm going to come back to this example a little bit later, right? But one of our definitions of openness is who has accessibility. Do I have to be a card-holding member of a club, or can I just go get the data? Right? There's also the issue of how is the data stored? Right? So there's some governments say, yep, we're going to do open data, and they go into their filing cabinets and they scan all their documents into PDFs and then they post them. Now we're open data. This is really not very useful unless you have a very good optical character recognition capability in your software. Right? I would really like open data to be machine readable. Scanning something and putting on a server so a human could look at it is not a full credit answer. Right? So, data is not a scanning of a document. Of course, that is a form of data, but full credit is it's machine readable with the appropriate metadata so I can interpret the data and provenance and all that other good stuff. How much do I have to pay to get access to the data? Right? How much do I have to pay? Anything more than 0 is friction. It means that I'm a kid in my college dormitory and I'm trying to innovate and I got no money in my pocket. If you charge me anything more than 0, then that creates a barrier to innovation. If that data is free, then I can try things out, I can run experiments, and by the way, most of the time, I won't create anything interesting. But that small percentage of the time when you get a breakthrough, it matters, right? Innovation is not something that happens every time you try something, right? I was speaking at a conference in Germany, and in this conference they were talking about innovation, and they were talking about, why don't we in Germany have a Silicon Valley, right? Germany has great universities, good technical skills, smart people. Why is there not a Silicon Valley in Germany? Right? And I was the only American on this panel. There were a bunch of sort of German, innovators and techies and all that kind of stuff. And my answer was, because in your culture, you're afraid to fail. Right? It's not in your culture to fail. It's an embarrassment to fail. Now, I've worked in Germany long enough to understand it's not true for all companies, but culturally in Silicon Valley, failure is expected. If you're not failing, you're not innovating. Right? Now, you're not allowed to fail in the same way twice. That means you didn't learn very well, right? So each failure is an opportunity for learning, and if you don't learn, then you really don't want you on the team, right? But failure as a process for learning and eventually getting to the pot of gold is part of the process of innovation, right? And so if cost is 0 for using the data, that allows me to fail more cost effectively. Right? That's the main point. The last thing on this list is rights. For what am I allowed to use the data? Let's come back to this example of the American Medical Association. You are only allowed to use the AMA data for the purpose of academic medical research. Let's say that I was an inventor of medical devices. And I had a great idea to invent some device that was going to help me sort of detect, early detection of Alzheimer's or diabetes or whatever it is. It doesn't matter. This would be a violation of the rules for use of that data if I use that data to help me innovate to build this new device. Right? So if you put restrictions on how I can use the data, then you will create friction for innovation. And the reality is, the best ideas are the ones you haven't thought of yet. As soon as you put restrictions, your restrictions will typically say, these are the things you can use it for, and they're always things I've already thought of, which means you're not going to be able to innovate effectively. So I'm going to encourage sort of the removal of these kinds of limitations. Those of you in software engineering may know about something called Linus's Law. Right? So you probably know Linus Torvalds, who's the inventor of Linux. Right? And Eric Raymond is an author in software engineering, and he named Linus's Law after the inventor of Linux. Given enough eyeballs, all bugs are shallow. What does this mean? It means that if you open source your software, and there are lots of smart software engineers looking at your software, the bugs will be found more quickly. Because if you have, let's say, closed source, you may have the programmer who wrote the code, and maybe you had one person do a peer review, and you had 2 sets of eyeballs. In the open source community, I can have hundreds of eyeballs. And a bug that you and I didn't see, one of those other 98 people, they're going to see it. So that's the idea behind Linus's law. Right? The more people that get visibility to the code, the higher quality code you get. Now, I should say that it's actually very controversial because eyeballs looking at code is not actually the most effective way to find defects, right? You're actually better off doing sort of automated testing, and there's a whole sort of domain which we don't have time to get into about how to do testing well. But I'm going to extrapolate Linus's law to the corollary about data. Given enough eyeballs, all insights are shallow. Right? The more people looking at data, the more likely it is that somebody is going to find something interesting. And if only one person can see the data, then you're relying on that one person's smartness to figure out the interesting stuff. But if I have 100 people looking at it or 1,000 people looking at it, then it becomes a lot more possible to find something interesting. Right? And so there are some companies that are doing some pretty innovative things around something called crowdsourcing their analytics. So I publish my data as an open data set. And by the way, this is commercial data now. I'm not talking about government data. We could also do it with government data, and I'll give you an example. With commercial data, I publish it, and then I let smart people go find stuff, and I share some of the rewards with them. Right? So how many people know Netflix, streaming video and so on? Yeah. So Netflix in Silicon Valley, not far from where I grew up, they had the $1 million data science prize. Right? So Netflix has an algorithm that will predict for each one of you individually what is the next movie that you would like to watch. Even a movie you might not have even heard of. We're going to predict that you would like to watch this movie. Right? And this is very important for the Netflix business model to keep you happy watching movies, especially ones that you didn't know about, because then you become happy, you use their services, you keep subscribing, and so on. Right? So they have this algorithm. They made a $1 million prize for who could develop the best algorithm for predicting movie preference. $1 million, that sounds like a lot of money, right? $1 million. But if you look at the price of a data scientist in Silicon Valley, right, and you know the result that they got, they had hundreds of people participating, right, and in the first few months of the contest, there were lots of submissions. 2/3 of them didn't even come close to being as good as the Netflix model, right? Which is understandable, right? I mean, Netflix is a sophisticated analytics company. But as the sort of crowdsourcing sort of matured to the really sophisticated data scientists, there were quite a few entries that actually outperformed Netflix. Right? Now, $1 million in Silicon Valley is basically loaded cost 5 data scientists for a year. $200,000 a year, including all the cost of their machines and all that kind of stuff, right? So they had hundreds of people working on this. This is a great deal. $1 million is cheap, right? And I'm perfectly willing to share the $1 million with whoever can deliver a great algorithm. Now, it turns out that the practicality of the algorithm submitted was actually such that they weren't able to use it exactly as it came out of the box, but there were certainly good ideas created that they benefited from. Right? In Canada, there's an oil and gas company that took its data, published it as an open data set, and said, okay, all you budding geologists, PhDs out there, if you can tell us where to drill for oil and you're right, we will share some of the money with you. Right? And so all these geologists get to analyze all this data, because if you're in a PhD program in geology, your hardest issue is getting data. So now all these smart people get access to data, they get a PhD, and maybe they get a cut of the oil money. Right? It's not so good these days because the price of oil is not so good, but in general, this is a very interesting approach. Now, of course, you have to be careful, right? So Netflix, you can't publish that, Stephen Brobst was watching this movie. That's obviously a violation of privacy, right? So they have to do certain things to protect the privacy of the data that they're publishing and so on, which they did do. Actually, when they first published it, there was a flaw, and you could actually triangulate and figure out who some people were individually by looking at enough data. It's not good enough just to hide name and address, right? You got to do a lot better than the name and address hiding, because a combination of, for example, postal code and birth date tells you an individual in most countries. Right? So you have to be smart about how you protect data, but it can definitely be done. Right? The Canadian Oil Company, as long as they're not looking to sell their land, then having that data out there is probably not really a big issue competitively. But for example, if they were going to sell the land, then people could analyze the data and figure out which land they wanted and how much to pay for it and so on. Whoever has information has the power of negotiation. Right? So you do have to be intelligent about it. So who knows this guy? Quite a few, not bad. This is Nick Cave, right? And Nick Cave is the kind of guy that would play in these music festivals. Now we're in the Belgian summer, which is the land of music festivals, right? With Ghent Festival and Tomorrowland and so on. And so Lollapalooza is the kind of festival that a guy like Nick Cave would play at, right? And if you go to Lollapalooza, I don't know if anybody's ever been to Lollapalooza, you will find a lot of black leather. You will find a lot of ink tattoos on people's arms and piercings in interesting places and so on. And so you're probably asking, so why am I showing at a data science meetup a picture of Nick Cave, other than that I really like Nick Cave, right? Because there's another set of people, not quite the Nick Cave type, right? But the idea of Lollapalooza and bringing people together that have a shared passion, right, was an idea of a guy named Todd Park. Right? Todd Park, you probably don't know who he is. He used to be the chief technology officer for the essentially the U.S. healthcare system. He later became the chief technology officer for the U.S. government. He was the second CTO under Barack Obama. Right? And he created something called Datapalooza. Right? So Datapalooza, which the Center here for Innovation is really doing the same kind of thing under a different name, right, is where you get some data set, some interesting data set, and you get a bunch of geeks, and then you figure out, what can I do with that data? What interesting thing can I create with that data? Right? And so what Todd Park does, he took the healthcare data, and healthcare is one of the biggest issues in the US right now. The healthcare system is completely broken. Right? So we need to figure out how we're going to innovate and make healthcare better in the US. And I'm very biased on this, but I think that data is an absolutely critical component of making the healthcare system more cost-effective, higher quality care, and so on. We've got to be smart about how to use data. So they attracted over 1,600 data geeks. Right? They had to close the door because there were so many people showing up for this thing. And the idea was to use this data, and again, it was completely privatized data, right? So there's not individual names and so on, but we had outcomes, like did the patient live or die, right? You had the procedure codes, like what did the doctors do to them, the diagnosis codes. You had a bunch of data in there that was interesting enough and detailed enough to be able to create some value. And then it's like, okay, let's go innovate. And by the way, not all the ideas were good ideas. Okay? That's part of the process, right? It's kind of like American Idol for geeks. Most of them are not actually that good, but there's a few stars that rise to the top that do really interesting things, right? One of the most interesting apps that came out of this, one that I like, is called iTriage. So iTriage is an app on a mobile phone that you could put in your sort of symptoms, your health situation, and would tell you which hospital should you go to for the most effective care. Right? Now, effective is a very interesting concept, because what is effective? If you just had a heart attack, effective is the closest hospital, right? If you've got a serious form of cancer, I might be willing to get on a plane and fly to a very far away hospital that has expertise in this particular form of cancer. And maybe I don't care about cost because it's cancer, right? I want to know the outcomes, how many people survive. That's my main criteria. If I've got an ingrown toenail, I just want the cheapest thing, right? It's pretty hard to screw up fixing an ingrown toenail. It's probably not that urgent, so I just want the cheapest hospital within some reasonable distance and so on. So iTriage will take into consideration all these different factors, right? How urgent is the care? How critical is the care? How important is cost? How differentiated is cost? And it will tell you which hospital to go to. It's very interesting. They were given a prize from the Datapalooza, contest and so on. But the big prize was they got the recognition, then got acquired by a big healthcare insurance company, right? So, and then that healthcare insurance company made the software available to its members and so on. So very, very interesting. Crowdsourcing analytics we talk about. We can also crowdsource data, right? So if we can convince people to provide their data, this is very interesting, right? So I was at the Ghent Festival last night. Anybody gone to the Ghent Festival? Yeah? Did you notice they have the urinals there where you pee, right? And there's a sign there, if you read it, it says, by peeing in this urinal, you are agreeing that your pee can be used for medical research. We're crowdsourcing data, right? You are providing your sample, so now we can get data from all the drunk people at the Ghent Festival, right? I'm not sure it's actually a representative sample of what they're trying to collect, except at big music festivals, perhaps. But, can we get citizens to volunteer their data? It's a very interesting concept, right? At MIT, which is where I'm from a university point of view, we did a very interesting project. I shouldn't say we, because I wasn't part of the project, but at the Institute, there was a project done where the idea was to collect data from citizens around where are the potholes in the road. So in Boston, we have a joke that there's only 2 seasons in Boston. There's winter and there's pothole fixing season, right? Because during the winter, we get lots of snow and freezing rain, and the road freezes and thaws and freezes and thaws, and this causes big cracks in the road, which become big holes in the road. And by the time the snow goes away, there's big holes in the ground. You're driving, and you hurt your neck every time you go over one of these potholes. So the idea was that we can have an app, and every time you drive over one of these potholes, you press a button, and it's a smartphone, so we collect the GPS location of the pothole, and then the city can analyze all the data and figure out where should I send the people to go fix the potholes. Pretty interesting use of crowdsourcing, because in the past we would have to pay a bunch of engineers to go driving around the roads looking for the potholes. Now we just collect the data and we analyze and we figure out where the potholes are. Now, very interesting thing happened when we analyzed this data. We found, not we, me, but MIT found, that there were a lot more potholes in Beacon Hill than in Roxbury. Now, if you haven't been to Boston, that probably doesn't mean anything to you. But let me put it this way. Beacon Hill, this is where the Cheers bar is. Beacon Hill is where the rich people live. Roxbury is where the not so rich people live. And Roxbury had many fewer potholes than Beacon Hill. Do we believe that? Absolutely not. Roxbury had many fewer iPhones than Beacon Hill, right? So you introduce bias by how you collect data, potentially. You have to be very careful, because the people in Beacon Hill, they had more smartphones at that time. Now everybody has smartphones, but at the time of the project, there were more smartphones in the pockets of rich people than there were in not so rich people. And so you introduce data collection bias by how you collected the data, right? So crowdsourcing data is very interesting, but be careful about the biases that you could potentially introduce when you do it, okay? Same thing with Ghent Festival, right? I don't think it's a random sample of people peeing in those urinals, right? It's a very select group. Having said that, let's talk a little bit about data collection and sort of innovation around data collection. Mobile phones and tablets are very powerful data collection devices, right? They can GPS encode any data collected. You can take pictures and tag them. You can have applications that allow you to do very simple things to collect data. And pretty much everybody knows how to use a mobile device, right? And a mobile phone or a tablet, even if you're not technical, right? Even my mother knows how to use these kind of devices, right? So we can use them for data collection. Let me tell you about a project that was done, a very innovative project in the Punjab region in Pakistan, right? So in Punjab region, the dengue fever is a huge issue. A lot of people die from it, right? So I had a friend who got dengue fever. Is actually not from Pakistan, but in Thailand. And this is he's a young guy, very fit. He was actually on the national team of football for Norway, and he got dengue fever. He was flat on his back for weeks, and he's a healthy guy. If you're not so healthy, if you're a little bit older or maybe very young and not as healthy, well nourished as he was, you can easily die from this. Right? So there was a lot of death being created by this dengue fever. And yet the government doesn't have a lot of money, right, to sort of do this. There's just not that much money. So how do you figure out how to fight this dengue fever? They used a very interesting combination of crowdsourcing of data using these mobile devices and a unique collaboration between university and government and commercial technology providers, right? And Teradata is one of those ones that participated in this. And what they did is when people came into the clinic and were diagnosed with the dengue fever, we would collect data on the tablet and figure out where did they live and where did they work. Because you get dengue fever when a mosquito bites you. So we're interested in figuring out where are the infected mosquitoes. And in particular, where are the mosquitoes breeding is the problem, right? And so we could do a bunch of analysis of where were the dengue fever cases originating from and figure out where we needed to pay attention to sort of get rid of these mosquitoes. And the mosquitoes, they breed in standing water, right? And so you want to get rid of the standing water. And the problem with dengue fever is if you get bitten by a mosquito that's carrying and then you get dengue fever, a healthy mosquito that bites you afterwards, it is now a carrier as well. So it will become epidemic very quickly, right? So we really got to get rid of these breeding grounds. So we analyzed where were the cases originating, and then we took the mobile phones and health workers went out in the areas which were high risk and identified standing water and took a picture of the standing water, right, which are geo-encoded, right? And then we were able to get a bunch of people to go essentially get rid of the breeding grounds. So breeding grounds, for example, if you have stacks of tires in someone's backyard, in the well of the tire, water accumulates, becomes standing water, and this is prime breeding ground for mosquitoes that will later become carriers of dengue fever, right? So we go over there and we turn over the tires, we get rid of the standing water, we teach them to put covers over the tires so it doesn't collect water. We try to get rid of all the standing water. Right? Now some standing water is too big to get rid of, so the water you see here, you can't just get rid of that pond. So you see these guys, they're dumping into the water a special kind of fish that eats mosquito larvae. So if we can't get rid of the standing water, we'll make it very unproductive for the mosquitoes breeding by sort of introducing these fish. Right? The success of this was huge. Right, so this is a geospatial map of where all the cases of the dengue fever were originating in the bad year, right? And there were hundreds of deaths, After we put this program in place, the number of deaths was, it wasn't 0, but it was, tens, not hundreds, right? So think order of magnitude improvement in the healthcare outcome with, by the way, no really huge investment. Okay, we had a few smartphones and tablets that we gave to people and so on, but the data was collected and used in some very innovative ways. The CTO of the Punjab government, very smart guy, he actually was around MIT when this other project was being done for the crowdsourcing of the potholes, and he used it for, in my opinion, a much more interesting application, right, is to fight this dengue fever. The last thing that I wanted to end with is a discussion of innovation and governance. And in this picture, so this 2x2 chart comes from a report that was published out of MIT about the relationship between governance and innovation, specifically in the area of big data exploitation. And like all good reports, we create some 2x2 matrix and you map a bunch of companies into the 2x2 matrix, right? And on the y-axis, we have low and high innovation. On the x-axis, we have low and high government, right? And the governance is around the business involvement in sort of driving value, right? And I raise this because, especially among technologists, we tend to think, governance equals bad, right? Governance is about moving slowly and lots of rules and saying no, right? Agile is about saying yes. Do whatever you want. Cowboy, innovation. It turns out that doesn't really work that way, right? So in this lower left-hand corner, low innovation and low governance, I call this the loser quadrant. If you're not innovating and you're not doing a good job in sort of running your business, governing your business, you will be out of business very soon. In the report, they were much more polite. I think they called it beginners because you can't sell consulting to people you call losers. But in the end, these are the losers in the lower left-hand corner, right? So you don't want to be in the lower left-hand corner. With low innovation and high governance, I call this the cash cows, right? Cash cow is a business where you don't invest a lot, you're not innovating, but you extract money out. Right? An example of this is fixed line telecommunications. Anybody from Belgacom here? No? Right? So if you look at fixed line telecommunications, this is a cash cow business, right? So at home in the US, right, AT&T sends my mom a bill every month, $50, she pays it. This is like $50 pure profit every month. Great. Good business. No investment, $50 every month per subscriber. Perfect. All profit. Right? Because the wire in the ground is amortized a long time ago. But there's a problem. This is not a growing marketplace. My little sister will never have a fixed line phone. Right? The phone rings, my mom goes running down the hallway. Hello. My sister will say, "What are you doing?" Why would anyone have a phone stuck to a wall? Why aren't you like a normal person? When the phone rings, you pick it up out of your pocket and you answer it. What's this nonsense of a fixed line phone? Right? So I imagine that many of your parents still have fixed line phones in their home. Right? I don't think any of your kids will have fixed line phones. It makes no sense. Right? And so what you want to do is you want to take the profit from the cash cow business and invest it in the innovation. And so that's what smart companies are doing, right? You notice the Belgacom brand is now gone. It's just Proximus, right? Right? So you can already see these things happening. AT&T isn't really about the fixed line, but they still make lots of money off fixed line. They just don't talk about it. That's just money in the pocket, right? And it funds all the other cool stuff that they're doing, right? So cash cow is not a bad thing, but it's not where your growth is going to come from because there's no innovation. This is how you fund the thing that you're going to innovate with. Now, if you look at the upper left-hand corner in the report, This is called the fashionistas. Right? Fashionistas love to chase technology trends, right? We love new toys, right? And, you know, sometimes I compare IT people with 8-year-olds playing football. Not American football, real football, right? If you watch 8-year-olds play football, when you kick the ball, or when they kick the ball, they all chase the ball in a big clump, right? They kick the ball, they all chase the ball, and they have a good time doing it, but it's really not a good strategy for winning in football, right? It's not a good strategy. You're not going to win the World Cup playing in this way. But IT people, we're like this, right? There's cloud computing. Oh, everybody runs after cloud computing. Oh, there's big data. Everybody wants to. Oh, there's Hadoop. We're all running out. We don't know why, but everybody else is doing it, and it must be fun, right? This is no good, right? It shouldn't be technology for its own sake. We need to understand, what are we doing with the technology, right? What are we doing with the technology? And that's where the governance comes in, right? So in the upper right-hand corner, in the report, it refers to the digerati. This term digerati, it comes from a book written by Nicholas Negroponte in the early 1990s. And at that time, he predicted the transformation of world economy from atoms to bits. Right? What does that mean? Atoms are electric toothbrushes. Bits are the data that you collect from the electric toothbrushes. What he's saying is the manufacturing of physical things, this is not where competitive advantage is going to be created. Competitive advantage is going to be created by the bits that you learn to add value on. Right? And today in 2016, this is pretty obvious, but, you know, 25 years ago, this was pretty insightful when he wrote this book. So this is where this term digerati comes from. It's from this Nicholas Negroponte book. He headed up the MIT Media Lab for many years. And he was actually a proponent of this one laptop per child program to develop cheap computers to go to kids that, you know, were not that were in developing countries and so on. So he's done a lot of very interesting stuff. But the point is, in the digerati, we're not just exploiting technology for technology's sake. We have a value proposition that we're looking to deliver, right? And so I'm going to give you an example from a large company that I work with. I'm not going to name the name, but they had a sort of IT department who was very excited about this big data thing. And the idea of the IT department was that they were going to do social media analytics. So we're going to get data from, you know, the blogosphere. We're going to get all the tweets and all the Facebook wall postings and the blogs about our brand and about our competitors. And we're going to understand sort of what do people think about our company. And they're very excited about this because this is big data analytics, and we're going to use Hadoop and use all kinds of interesting natural language processing technologies and so on. Very, very cool stuff. It will look great on my LinkedIn profile, right? And the business guy, to his credit, said, "It sounds like a very interesting project, but I don't know what I would do with it when you're done." Okay, I could make some PowerPoint slides. I can show them to the chief marketing officer, maybe present at a couple of conferences at Strata and so on. It'd be fun. But what value am I going to create? And in the end, he pushed back. And he said, "I know that it's very boring in 20th century, but you know, the call center data, it's actually very interesting. I know call centers, it's not cool, and social media is very cool, but you know, we still do a lot of customer contact in the call center. When someone calls the call center, I know who they are. If someone tweets, I probably don't know who they are. And when they come to the call center, they've got a specific problem that we need to solve. We understand their value and their relationship and so on. And so I want to exploit that data. And by the way, voice data is also big data. As they took the voice data and they translated voice to text, right? Which is interesting technology by itself. And you know, 20 years ago, this was artificial intelligence, and that means impossible. Today, this is just standard technology, right? You can talk to your iPhone, it talks back to you. It uses exactly these kind of technologies. It's now available to data scientists to do this voice to text. And the text, by the way, of course, isn't very interesting either. I have to do natural language processing to do fact extraction and dimension extraction and sentiment scoring. And that technology is no less interesting than the fact extraction, dimension extraction, and sentiment scoring that you would do on social media. Only we're doing it on the text of a phone call conversation. But in the end, it translated to value in terms of retention programs and cross-selling programs that were much higher than what they would have gotten had they gone and chased this very cool, sexy social media, right? So you can have sex or you can have the money, right? But you know, with the money you can buy the sex, so the other way around it doesn't work. So I recommend the upper right-hand corner. Right? So with that, thank you very much for spending this last hour with me. Thank you.
So we still have half an hour, and I propose that we use this half an hour for some interaction. So the way we will do this is that if somebody wants to ask a question, he asks the questions to Stephen. Stephen will repeat the questions so that we can record it and that everybody hears it and answer the question. Is that okay for you? Is half an hour okay, or do you want to stay longer? The only problem is that the beer is getting warm. So, so let's aim at closing this down at 5, 5:15, whatever, how we feel it. And then afterwards, Nele will again say that you have to fill in the survey to see if you're satisfied. And then we are going to have a drink and continue conversation. So who has the first question?
I buy the beer for the first question.
Who was the winner of the Netflix contest and what did they contribute? Do you know?
So the question was, who was the winner of the Netflix $1 Million Prize contest? Actually, that's an interesting story by itself, because the winning team actually was two teams that actually came together, because they each had an algorithm that was very good, and when they put the algorithms together, they became even better. So it was a combination of some sort of, I would say, commercial data scientist and a university team that came together. And the problem with the algorithm was that it was so computationally intensive that as it was implemented, because there were no rules about that kind of thing, as it was implemented, it wasn't that practical. But by doing some simplifications and so on, then there was some interesting ideas in there. And in fact, the winning team then went on to do a startup company to sort of commercialize some of their stuff.
Next question, please.
Yes, thank you. You talked about encouraging people to volunteer to collect and give their data. What about companies paying consumers to get the data?
Yep. So the question is, you know, we can talk about sort of getting people to volunteer their data. Can companies pay people to get their data? And the answer is certainly that happens already, right? And payment can be in many different forms. I can pay you not necessarily in money, but by giving you a service that you want, right? So if you use Google, Google is paying you by giving you a free search service, but in exchange, Google gets the data about you, right? And that data about you is actually very interesting, because if you're searching for, you know, beach resorts in Croatia, then you're going to start seeing ads, you know, on your on the side of your browser about, you know, hotels in Croatia and Split or whatever, right? And so payment can be in many different forms, right? Google gives you free email. Isn't that very altruistic of them to give you free Gmail and no limitations on the size, right? Do you think that they're not looking at the content of your email, right? Now, I don't mean individuals. So the whole point is that individuals don't look at it. Your data is still protected from a human privacy point of view, but actually there are machine learning algorithms that are learning about you based on the emails you exchange with your friends. So you can be paid in the form of services even if you're not paid in euros, right? So absolutely, this happens done all the time. It's usually not in money, but in some kind of service that you want, right? And I find it interesting because, you know, people get very, very worked up about this whole privacy thing. right? Privacy, we got to protect the data and so on. But if you give them a free t-shirt, they'll fill out a survey of 200 things about them, including the age of their kids and their dog's name and their income and so on. So privacy is really a question of how much is it worth to you. And for some people, there's no amount of money that you can pay me for me to give you my data. That's fine. That's their choice. For other people, it's a matter of what, to your point, what do I have to give you in order for you to share the data? And there's another aspect of it is, well, I'll give it to you, but only if I trust you. I'll give it to you, but not the other one, because I know that this one treats the data with more security and will not give it to other people and so on, whereas this one, they give it to everybody, right? So there's also the conditions of use. So when you pay me through a service or through money to get my data, an intelligent consumer is going to have some level of understanding of how that data is going to be used.
But don't you think that there's somehow a change? Because, for instance, I'm a Spotify user.
Yes.
And I like the fact that I get some free space from Google to use Gmail for free.
Yes.
But now I'm ready to pay €9 per month to use Spotify without having to be harassed by advertisement and those, like cuts in the song. And I'm ready to pay again, not to be given a service that I don't want to be given.
Right, but what you're paying for, so the question here is about, at what point will people be willing to pay for the service instead of data? Now, in the case of Spotify, you're basically paying not to get the advertising, but they're still getting all your data. Right, so that's not really the issue. So the issue is how inconvenient is the thing. People will pay not to get advertising, right? So I pay for Netflix because I want to see the video not interrupted by boring commercials because I don't want to watch television, right? Nobody I know watches television anymore, right? And they're willing to pay either for a TiVo so they can record and skip over, or they're willing to pay for a streaming service with no commercials, right? But data is a little bit different, right? So am I willing to exchange something for the data? Because the problem with consumers is they don't actually understand the full value of their data. So most consumers are willing to give away their data for very little. And an example of that is you can go on the internet, and there are a large number of people who do this, fill out all these very detailed surveys so that then you can get scored on, are you on the Myers-Briggs spectrum, or the how old. There's one of the very interesting ones is a survey, how old are you really? Right, so I'm 50 years old, but how are you really? Am I and I really, oh no, I'm more like a 30-year-old. I go hiking mountains and so on. So you can fill out this big survey, and they ask you all kinds of things. When's the last time you were at the doctor? Have you lost any teeth? Have you all these kinds of things? How much do you hike? It's extremely detailed information. That information is very personal, and by the way, highly valuable for certain kinds of marketing and profiling and so on, segmentation, etc. And all I did, I gave you all that data just so I could be told that I'm a 50-year-old that's really 42. So I mean, yeah, I gave a lot of data away for something that I would argue is pretty low value unless you have a very big ego, right? So people undervalue their data is the point.
Actually, I wanted to ask regarding possible crowdsourcing problem. Well, there have been one crowdsourcing project somewhere in the beginning of 20th century, well, in the first half. It lasted for almost 100 years. It was about the Fermat theorem, so this mathematical problem.
Yeah.
The problem there was that this question was understandable even by people who just finished the primary school. It was so easy. So in the end, there have been crowds and crowds of people trying to get to the universities to get their proof verified. And of course, well, it didn't work for 100 years. It was still unsolved until the late times. And now I think it's either solved or partially solved. So how do you deal with overpopulation or over-interest or the poor results that you can get from crowdsourcing?
So you have to, the question is around crowdsourcing, not data, but analytics in your case, right? So crowdsourcing the analytics, how do you make sure that everybody who's submitting their ideas...
In case of Netflix, well, in Netflix it was serious teams, but let's say you do something on a larger scale.
No, but in Netflix, anybody could, any non-serious team could do. So the point is you have to have an automated way of evaluation.
Yes.
So when I submit my model to Netflix, it doesn't mean that a human had to go analyze it and so on. Like in the case of Fermat's theory, the solving of that problem, it took a math professor to look at it and say, no, this is no good. You have to be able to automate the process of evaluation in order to scale it. So all the successful ones that do this kind of crowdsourcing analytics, they have some automated way to filter out the stuff that doesn't work by sort of doing simple testing on whether the algorithms are sufficient for being interesting.
And does it work for every problem, or they're like?
Every problem is too strong a word. I never say never, and I never say every, right? But for the most part, yes, you can develop some tests to indicate whether the analytics are viable or not. Right?
Yeah, what Netflix did with the consumer information they had is difficult to replicate in, for example, the banking industry, where consumer data is a lot more protected. Any other idea of how that could work?
So the question is, in the banking industry, the data is a lot more regulated than in the streaming video industry, clearly the case. Are there ideas of what you can do? I think not all commercial organizations will be able to do that easily. I do believe that in the banking industry, the idea of consumer intelligence is very important. So I should at least provide the data and tools to my consumers to allow them to make personal decisions. And I could allow the community to develop tools to help consumers analyze their own data and so on. So I can imagine startup companies developing tools that will, and if I provide an open API that can be used to access the data, but only the data that I have the access rights to, you could sort of do some innovative things around those lines. Banking industry, by its very nature, is conservative. It's risk averse, so it's not all the way there yet. Banking industry is doing consumer intelligence. Are they ready to open up APIs for data and third-party apps and so on? That's a little bit more tricky, but there are some companies that are doing that kind of work. Yeah.
And just comment on this. Sorry, BNP Paribas published a competition in Kaggle recently, so they published the data set.
Yeah. So Kaggle is one of these platforms for doing this kind of crowdsourcing analytics. Yeah.
But how can you get to insights and data if you don't necessarily want to share them with a lot of people? Because you cannot share them, but there might be value in there.
Well, so in the case of Netflix or other people crowdsourcing or the Canadian oil and gas company, they share the data. They don't necessarily share the insights, right? So I submit my algorithm to Netflix. It doesn't mean Netflix is going to publish the algorithm. Now, I still own that, and I can decide to publish it if I want to or not, right? But you really need the combination of the algorithm and the data. So if someone has the Netflix algorithm but they don't have the Netflix data, it's not that useful, and vice versa.
And so how do they get to the algorithms? And you need the sample data to be able to make sense of data, or is that purely based on a theoretical?
No, so they do need the data. So Netflix used real data. Now they anonymized it, so you wouldn't know who was watching the movie and so on. They used real data. And that's one of their competitive advantages to someone who comes into the industry brand new. They don't have any data, so Netflix will have a better search engine, recommendation engine than the incumbent. So if you don't use the data as a competitive barrier, then you're doing a bad job, right? You should be using that data to develop your algorithms.
If you look at your dream to have like a zero cost of open data, for example, if you look at private data, for instance, if you look at the Fitbit device, it comes with a dashboard and some BI. But then if you want to dump your personal data, you have to subscribe or you have to pay for it. So you actually get a device that registers your own data, and then you have to, let's say, pay money to get your own data.
Yeah.
And that's a good working business model for now. But like, if you look at Obama making it mandatory for governments to free up the data, do you think it's also possible that laws can lead to, let's say, this small devices, etc., that will oblige that openness, because if you just leave it to let's say.
Yeah, so the question is about sort of open data, and can we sort of expand the idea of open data, and like government does. In the case of government, the idea is that the taxpayers have already paid for the data, so they shouldn't have to pay for it again. That's kind of the concept, right? Now, there's a very interesting case in the UK. The UK is actually quite advanced in this open data initiative, and the post office has a data set of people who moved address, right? So if I move address from, I don't know, Manchester to London, I register with the post office and they will forward my mail, right? So I get a service in exchange for sharing the fact that I moved, right? So this goes back to your point. I get something, you forward my mail if I tell you I changed my address. Now, it turns out that change of address is really very interesting for people that are selling stuff. If someone moves home from one address to another address, at least in the US, within the first 6 months after they move home, they will spend $50,000. New furniture, paint the walls, new blinds, whatever it is, those things that they pay, they buy, right? And so the retailers want to know, as soon as someone's moving, I got to get to them, right? And so the UK Post Office, as well as the US Post Office, they sell this data. And so the UK Post Office, as part of the Open Data Initiative, they say, we're opting out. We don't want our data. We're not going to make that open data. And it got taken to the Supreme Court of the UK and got overturned, and they were forced to give the data as part of the Open Data Initiative because the taxpayer already paid for the data, and why should they have to pay again, and so on. So it's quite interesting. Now, if you're a commercial company, there's no government official that's going to make you do it. So you have to decide, is this going to give me enough value that it's worth it for me to do it? And and value also has to be weighed against, does it give my competitors some advantage against me, right? So the Netflix data, in some sense, someone who is entering the industry could download all the Netflix data and maybe do something interesting with it and kind of use that as a bootstrapping. So you do have to sort of think about competitive advantage and what are the incentives, right? Government's more natural because government should always be acting in the best interest of the citizens. And so there's not a commercial motive like there is in the sort of company land.
You talked about open data in the sense that it's machine readable. There's also, I think, a big movement for linked open data, which takes it one level up, which is machine understandable. You ask Google, who is the president in 2016, today it will respond to 1 million hits. In the future it will say it's Barack Obama. Do you think that business intelligence and linked open data will come together to form some next level of intelligence, merging these two technologies?
So the question is about taking open data to the next level, from machine readable to understandable in a more sophisticated way. And in your example, there are sort of ontologies that would be used to encode data and so on. So yeah, this has been an active area of research in artificial intelligence for decades. And you see stuff like Steve Wolfram is doing some very interesting work in that area. IBM Watson is generally in that category. SAP is doing some things in that area. So there are definitely people doing expert system type of work to interpret language and understand ontologies and knowledge and cataloging and doing some interesting things. It's a little bit separate than the deep analytics on the data, but related, right? Because first I have to understand the question, which is what a lot of that is, and then I have to relate to data. Who is the president of the United States in 2016? There's no analytics. That's just a way of understanding and then looking up. So the famous example of Watson beating the world champion in Jeopardy, there's really no analytics there, right? This is really just a very efficient way of cataloging information and organizing information and understanding language and then translating that into an answer. But I would argue there's zero analytics involved in beating the world champion in Jeopardy, right? So they're separate things, but related.
How do we ensure the open data is used for legitimate purposes?
The question is, how do you ensure that open data is used for legitimate purposes? you know, this is an interesting question because it goes back to the rights discussion, the fourth part of the McKinsey framework for openness. Who gets to decide what is legitimate? I'm not trying to turn the question around on you, but you know, as soon as you start to decide who is legitimate, is it not legitimate to use healthcare data to do device innovation? So the American Medical Association thinks that's not a legitimate use of their data because that's not academic research and publishing. I personally think that's a very legitimate use of that data, right? So you know, I think that maybe you're going a different direction as well. I can use it for, let's say, crime, right? So, for example, if I get the smart home data, part of the smart home data is about electricity consumption and all this kind of stuff. If there's zero electricity consumption, I'm pretty sure you're not at home, and I'm pretty sure I could rob your home. So that data should be, you know, not open to everybody at a detailed level. So the answer to your question is, detail can often be abused and misused. And you have to be very careful at what level of detail you're willing to give out. And as I mentioned earlier, simple scrubbing of name and address isn't enough, right? Because smart people can triangulate data and sort of decode to a level of privacy that might not be appropriate, right? But in the end, I believe that the data should be, in this case of, you know, automotive and healthcare and so on, it should be consumer data, and consumers should be educated about sharing their data and who they should share it with and for what purposes. I also think that there's some government role in the equation to make sure that when companies publish a privacy policy, that they do what they say they're going to do, right? Well, the opt-out, like if I opt out, then there's penalties if you still use my data, even if I don't. So that kind of thing. So I think that it's important that consumers retain control of their own data, but I think the biggest problem is educating consumers so they aren't silly about who they give their data to. Right?
What is the major challenges you have seen so far with the open data?
The question is, what are the major challenges that I've seen with open data? The main issue is who's going to pay for it. Right? So, you know, even in government, right, you know, publishing open data sets, there is a cost to doing that. Who's going to pay for it? Right? And who are the beneficiaries of it and so on. With commercial data, you know, it's even a little bit trickier because, you know, I already paid for it, and now the question is, should I make it open or not? Because I paid for it, it should be my decision, and I believe it is the company's decision of what to make open and what not to make open. But if you can use the data to innovate, I get paid for it by the innovation, right? So in the healthcare system, if I can get better healthcare by sort of publishing that data, and healthcare is very tricky because healthcare data is probably the only data people consider more private than their financial data, right? I mean, it's very, very private data. On the other hand, the upside of sharing of that data can be very, very high, right? So there's a brilliant physician who's a big proponent of this open data initiative called Hans Rosling, who's done some amazing stuff in visualization. He's been very involved in the you know, working on the Ebola epidemic, and he's at the academic institution in Sweden. Brilliant guy, and he's making a very big push for healthcare data within, you know, limitations of privacy and so on should be public data, because then we can improve the healthcare system by doing that. And I think he's right.
So what about the cross-country conflicts about using the open data?
Cross-country conflicts of open data. You're maybe talking to the wrong guy now, because I'm not a very strong believer in borders. So I think that most of this cross-country politicians, I'm not a very political guy. I think most politicians should be put in a closet and let the people do things. So I'm maybe not a good person to answer that question, because I think that sharing is a good thing. And I think if we share across borders, then we will stop thinking about borders and we'll start thinking about people instead. Because I think borders are not important, people are important.
US published the majority of the information.
Let's move on to another question. Sorry, you have three.
Okay, please.
Yeah, so you said at the beginning that everything would be kind of data related in the future. Anything, any product that you build with data, any data set which is byproduct of Analytics built on data actually contains part of this data, and there are, for some reason some data sets we just can't cross, actually. For instance, there are regulations with some incentives or whatever, I don't know, between crossing bank data with insurance data, and okay, it has to be enforced in some way. But as you grow with open data in the mix, you might want to have really fields of data that you don't want to cross, like open data on health could not be crossed with with data, well, by insurances basically, with their own data. These kind of regulations that might pop up. And with all those machine learning and side products that you can cross them without realizing. So it feels like we can't have both.
So the question is about I'll say the risks or the dangers of multiple data sets being put together and leading to undesirable outcomes. And I think the main point in answering that question is if I protect the level of detail on that data, then I can avoid most of the bad outcomes. Now, I do want some crossing of data, like the example I gave earlier. I want the weather data and the quality of soil data. I think that's actually a very interesting and useful crossing, right? I don't necessarily want a crossing of data about individuals that a healthcare insurance company could use to say, well, you know, let's say that I have a genetic defect in my family that leads to some kind of heart disease. Does that mean the healthcare insurance company should give me a higher insurance rate or deny me coverage because they know there's a high risk? I think that would be immoral, because now it's no longer insurance, right? But if you can protect my identity and we can help the healthcare insurance company do a better job treating people with this genetic disease on healthcare, then I think it's a good outcome. So I think you have to, it's the level of detail which you expose the data matters. So when I talk about open data, I definitely do not mean that all data should be published in the lowest level of granularity in a personally identifiable way. I think could be a bad thing.
The problem is that with very high dimensionality, lots of crossing of different data sets, you find lots of correlation which at a high level of granularity still cause things that might be unfair. Or with, say, if it concerns more than 1,000 persons, then it's okay. I don't know.
Yeah, so you can set thresholds. So that's the granularity question that you're raising again, right? Because with high dimensionality data, even if I again get rid of the obvious identifying things with high dimensionality data, there are other ways of triangulating and finding. That's what happened with the Netflix data, right? It was very high dimensionality data, and that became a problem. But they fixed it by sort of adjusting the granularity of the data that they published. So it does require, I mean, there's a whole field of academic research about sort of what level, given the dimensionality of the data, what level do I need to sort of hide in order to protect the identity of the data?
Let's agree on 3 more questions. And we have another 5 minutes to go. Let's go for the last 3 questions. Think of them carefully because there are only 3 left. Or not too carefully.
I was just making a question, Steve. If you're taking a look at what's happening in the world today on terrorism, and you're talking about data quality and data privacy on the one side, and governance and innovation on the other side, don't you think people are ready to be more willing sharing data because they are feeling more protected on the one side, and then on the other side governance will be more obliged to be investing in innovation just to protect people? And technically spoken, everything, you know, is almost possible. I think we will have to invest also in data.
Yeah, so your question is an interesting one about the trade-off between sort of privacy and security. And in some ways, it's really the same question that you asked, which is, am I willing to trade data about myself for higher security? That's the service that I'm getting, right? And you know, if you're in a democratically stable government like Belgium, you're probably reasonably, assuming you're not a terrorist, you're probably willing to share your data because the upside of sharing is much better than the downside. But if you're in a government which you don't trust, right? then I'm less willing to share the data, right? Because then the risk to me as an individual, if someone is going to persecute me for having green hair or for my sexual preference or for my ethnicity or for something like that, right? I mean, and there are definitely governments and politicians that do persecute people for these things, then I'm less comfortable with that. Right? So the answer to that question depends a little bit in my trust, just like it depends on the trust of the company I share data with, it depends on the trust that I have with my government. Right? And I would argue some governments are more trustworthy than others. Right? So. Yes.
One question, you mentioned before the risk of bias related to the way data is collected. You can take that into account if you're working, for example, if you're a scientist working on a study, you take that into account in your conclusions. But when you're a consumer, you cannot think of that, and it might increase this bias impact.
Yeah, so the question is around this sort of data collection bias. You know, I'll say data scientist professional will hopefully know how to deal with the bias in some way. By the way, it's not so easy, right? But assuming that they're at least aware of it, they can adjust their conclusions effectively. Consumers are not data scientists, at least not the people outside this room, right? And so part of the job of us as the data scientist profession is to provide tools to consumers that help them make good decisions despite their lack of knowledge about the data and statistical, you know, the average consumer doesn't know what R squared is, right? But we do. And so we should help them understand that really you shouldn't use this data for decision making if you don't have X number of samples, if you don't have, you know, this level of confidence in the data and so on. So I think that's part of our responsibility as data scientists to provide frameworks and applications that help consumers make better decisions.
It's not that easy because if you are a consumer using an app, you cannot decide on, for example, what kind, if the sample of data behind the recommendations in the app are high enough to be.
That's absolutely, it isn't easy. I agree with you. But again, I think that it's the person, the company or the software developer making those recommendations, their responsibility not to make recommendations without a critical mass of the sample, or they're just bad recommendation. Now, it depends on the recommendation. If I'm making a recommendation on sort of which hospital to go to for healthcare, that's much more important than, you know, what color of blouse should you buy. Right? And
the hospital might have a little one that only receives, for example, 100 people, and another one that receives 10,000.
That's right.
You cannot compare the amount or the number of recommendations that both of these.
So your example is why this sort of open data initiative, where you shouldn't look at data just from a single hospital. So iTriage uses data from the Center for Medicare and Medicaid Services, right, in this hackathon, this Datapalooza thing, and that is a huge percentage of the healthcare claims in the US. It wasn't just some small hospital. So it works on a very, very large data set. So, you know, we shouldn't use applications that are deployed on small data sets where we're going to get wrong answers. And, you know, just like any product reviews and people who understand the product will write reviews and say this app is no good because its recommendation engine is not using statistical significant data. And, you know, my mother can understand that the product is no good. She may not understand all the data science, but if she believes the reviewer and the reviewer is reliable, then the right things will happen. So I believe in the power of the marketplace to expose good practices and bad practices.
Right. Are we ready for the last question?
Sorry, question. When we are in terms of text analysis, you mentioned that there are some companies already working on factor analysis or dimensions.
Oh yeah, there's lots. So the question is, where are we in text analysis? There's lots of work going on in this space. So fact extraction, dimension extraction, sentiment scoring, this is commercially available, and there are open source tools available to do these kinds of things. So it's out there. You can definitely get it. Right. Okay, well, thank you very much for